So with these types of exponent questions, there are a couple standard approaches. And the first thing is to kind of notice these bases and see if there's a relationship. So I'm not familiar with this large number, but I'm tempted to think that it's going to be some power of 8 or 2 if you want to go to even lower prime number as the power of these numbers. So first thing I'm going to do is use the calculator, divide by 64, which is 8 square, and we get 512, and some of you might recognize that's 8 cubed. So essentially 32,768, either way, we need to recognize that that's 8 to the 5. Now, once we have that, what we'll do is to rewrite everything in this base 8. And that's what I'm doing here with that piece. And I'm going to do that for the other side as well. And this would be 8 to the 5 to the power of 1 over k. So the goal with all of these exponent questions is to write this with a as powers of the same base on both sides, and then we can equate the exponents. So here it will be k plus 5/3. Here that's multiplication rule here, and then again it would be 1 plus 5 over k. So these exponents have to be equal for this equation to hold true. So that's what will give us our k values. Now notice the question is the sum of all real values, so they don't really expect you to find the value of k itself. And in fact, for that reason, you can't really use the answer choices and plug in. These are not values of the k. These are the sum of the possible values of k1. Let's say these are the two values. This is what we're looking for. And you'll immediately notice this is going to lead to a quadratic equation. So I'm going to subtract 1 and then turn this into a quadratic. And then cross multiply 3k squared plus 2k is equal to 15. So that's our quadratic. And again, we don't have to solve this by factoring because they're asking for the sum of those two solutions. So sum of roots, if you have this general quadratic equation, the sum of the two roots is minus b over a. We're going to apply that here. A is 3, b is 2, so that sum becomes minus 2/3. So you can skip the step of finding the individual roots. So the answer is the sum of all real values of k for which this equation holds true is minus 2/3. Answer choice D.